Good morning, this is your stats sensei, Mr. Spensey, and we're going to work on two sample proportions. And in this particular video, we're going to break down run a full confidence interval. So the scenario is treat me right. A French study was conducted in the 1990s to compare the effectiveness of using an instrument called a cardio pump with the effectiveness of using traditional pulmonary resuscitation or CPR in the saving lives of heart attack victims. Heart attack patients in participating cities were randomly assigned. Oh, that's a key word. That's a key word because that tells me that it's going to eliminate one of my, I won't have to do one of my conditions. One of the conditions won't have to be done. To being treated with either a cardio pump or CPR, depending on whether the individual's heart attack occurred on an even number or an odd numbered day. Before the start of the study, a coin was tossed to determine which treatment, a cardio pump or CPR, was given on the even numbered days. The other treatment was given on the odd numbered days. In total, 754 patients were treated with a cardio pump and 37 survived. All right, that's going to be important. Sounds like we have a sample size of 754. And it said that 37 survived. So we know that P hat 1 is going to be 37 over 754. So 37 divided by 754 is 0.049. 0.0490. And while 746 patients were treated with CPR and survived. So this is the pump. This is CPR. So in this case, we had 746. So we had 8 less patients, so almost the same. And 15 survived. That's a kind of seems like a big difference. So this is going to be 15 over 746. Just looking at this, it appears that the cardio pump is substantially better at saving lives. 2% versus almost 5%. So 0.0201. All right. Let's go ahead and start defining things. We've got our important information down. We know what we're doing. And one thing I noticed, I didn't have a population, and we'll talk about that when we get to our conditions. So let P1 equal the true population survival rate for those receiving cardio pump treatment, but I'm going to say those using the cardio pump. I know that's not quite right, but it'll have to do for this. Next thing, let P2 equal the true population survival rate or survival proportion for those using CPR. Now, I probably should use the word instead of rate. I should have used the word proportion here in both places. The true population proportion for those who survive, for those using cardio pump, the true population proportion for those surviving, for those using CPR. Conditions. We don't have random assignment. And by the way, this is the cardio pump. And this is CPR. We don't have, we have random assignment. They were randomly assigned. So random assignment and that was given. It was not a random sample. And over here, random assignment, and that was given. Number two, two independent groups. Two independent groups. The third condition, the N is less than 10%. Well, first off, they didn't give us the population. Secondly, we don't need it for random assignment. So for number three, we can leave that blank. We don't have to do that one. Number four, that's when we need to talk about normality, which is N1 times P hat 1 and N1 times 1 minus P hat 1. N1 was 754. P hat 1 is 0.0490, so 0.049, and that equals 37, and that's greater than 10. We're good to go. Then we go step equals 754 times 1 minus 0.049. Parentheses 1 minus 0.049 times 754. And that's 717. And 717 is greater than 10. So that's good to go. On the other side, it's not N1 P hat 1, it's N2 P hat 2 and N2 times 1 minus P hat 2. And in this case, we have 746 and 0.0201 equals 746 times 0.0201 equals 746 times 1 minus 0.0201. When I multiply 746 times 0.0201, I end up getting 15, which is greater than 10. And then I come over here and I go, okay, 746 times parentheses 1 minus 0.0201, and that's 731. And that's also greater than 10. So we met normality here, we met normality here, so we're good to go. Now we need to write down our formula. Our formula is going to be P hat 1 minus P hat 2 plus or minus Z star P hat 1 times 1 minus P hat 1 over N1 plus P hat 2 times 1 minus P hat 2 over N2. The next thing says calculate Z star. So this is going to be an inverse norm. And our area is going to be 1 minus 0.9. They want us to run a 90% confidence interval. So our C level is 0.90. 1 minus 0.90. Make sure that's in parentheses, divided by 2. And we're going to go left if your calculator has that. So second vars, inverse norm. One clear, so 1 minus 0.90 divided by 2. Make sure everything's in parentheses. Mean of 0, standard deviation of 1 because it's a z-score. And we end up getting 1.6448. Make it positive. So 1.648. And now we can go ahead and plug in to our formula. So P hat 1 is 0.0490. P hat 2 is 0.0201. Plus or minus our Z star is 1.6448. And because we have a shortage of room, I'm going to shorten these up a little bit. Instead of 0.0490, I'm going to do 0.049. So 0.049 and 1 minus 0.409. 1 minus 0.049 is 951. So 0.951. All that over the sample size of 754, plus sign. And then this is going to be 0.02, because it's 0.020. This is 0.98. This is over 746. At this point, I can go ahead and run my interval. Stat test letter B, which is 2 proportion Z interval. And in this case, we had 37, 754, 15, and 746. And we wanted a 90% confidence interval. And I end up getting 0.0135 and 0.044. So my interval is 0.0135 to 0.0444. So doesn't contain 0. So it looks like it's going to be statistically significant. So here we go with our conclusion. We are 90% confident that the true population proportion, or true population difference in proportion, true population difference in proportion. Hold on for just a moment. I need to put pause for just a second. So, excuse me, we are 90% confident the true population proportion difference between survival rates for the cardio pump, or for survival rates difference in survival rates between the cardio pump and CPR lies within the interval 0.0135 and 0.0444. So let's try that again. We are 90% confident that the true population proportion difference in survival rates between the cardio pump and CPR lies within the interval 0.0135 and 0.044. And like I said, 0 is not contained. So it appears the cardio pump has a higher survival rate than does CPR. All right. Appreciate you watching. Thanks for, and I hope you'll tune in for the next one. Thank you.